Hello everyone. In this video I'm going to show you how to map a toolpath to an irregular surface using the autoleveler plugin that it's made by Cahit Ates from Netherlands. This plugin is for using on the usign, and the origin of this plugin is to fix the bed of the CNC. Sometimes it's not even. So when you're milling, for example, PCB material, you get this kind of error, as you can see on the image. If you see the image on the left, there are some parts that are not milling because of the bed is not flat. And with on the right image, you can see the milling is okay because it uses the autoleveler plugin. These plugins have some other uses, not only this one. Because the ability of these plugins to level the surface, another cool thing is that you can have a very irregular surface and map the toolpath to that surface. So that's very cool. And that's what we're gonna do. Well, the next step is download the files from the links on the description, and you're gonna have these two files, the autoleveler and the macros for the 3D probe. You need to unpack this one first, and then you're going to unpack this one. Okay, what we need is another window, and we need to go to the usign, and here you're going to find this folder that says plugins. I already have the autoleveler installed. To install this, you need to double click here. If you have Windows, you're gonna see a Windows like this with the two files. You need to move the DLL to here. It gives me an error because I already have it. And the macros, this is very important because you need to go to the usign, then go to your profiles, and you're gonna see there is a macro folder with the model of your machine. Get inside here, and you're gonna move this macro, the M331, through here. And of course I already have it, so that's why I get this error. Okay, after you're doing that, stay on the macros because you're gonna need to install all these macros from here. So I'm gonna open it the same as you're gonna look, and all these macros are the special macros for the 3D probe that I made. This one have the description of the macros, and all these have the macros itself. Okay, the description, I recommend you to read it and to learn the macros. I'm gonna make another video for these macros, so it's okay. We are not gonna see this now. The only thing is, this is a replacement for the M331 macro that allows you to write the 3D point cloud to the hard drive. Okay, so you need to replace that macro. Okay, I'm going to move everything here, and of course I already have everything installed, and I recommend you to read this. Okay, after we install this, Now we need to load the usign and activate the plugin. Okay, we load the software and we go to the configuration, general settings, and here we're gonna find configure plugins, and we're gonna find the autoleveler here because we already moved it. Okay, what we need to do is enable and call it at startup. Okay, we need to close this, apply, and then save settings, and that's it. To make it work, we need to restart the usign. So I'm gonna close the usign. Yes, and I'm going to reload the software, and you're gonna see the plugin it's activated and ready to work. Okay, now we have software and here is the plugin. If you can read, it says first load file in usign that then come back. Okay, here we're gonna load our toolpath, and after that we're gonna use this plugin to wrap the toolpath on the surface. But first we need to do some things. We need to attach our material to the to the machine. Also, we need to attach the probe, the 3D probe, so we can scan the surface. And also, we need to measure the difference of the distance between the 3D probe and the endmill, because they have different lengths. So we need the the offset between those two to have the exact position for the endmill. Okay, I finished the toolpath that I'm going to use to engrave it to the curved surface. It's a normal toolpath, it's only a carve. Okay, after I save this, I'm going to go back to the usign and I'm going to load the toolpath I made. Okay, here you can see the normal toolpath, and if you go back to the plugin automatically loads also the toolpath. Now, here's how this thing works. We have several options here, and we have a button that says create G-code and send back to the usign. What the plugins does, it's gonna make a new toolpath that's gonna do two things. The first one is gonna scan the surface, and after it scans the surface, it's gonna mill the toolpath that you see here. Okay, the first options that we have, it's the probe clearance and the probe depth. These ones are important. The first one is what's the length, the height of the probe that's gonna be on top of the 0 point of the probe. In this case, you see this X here on the middle. It's because it's going to start probing from the center. So you're going to put the probe in the center, in the top of the material, and this 5, it's going to be 5 millimeters. Is going to be on top of the 0 from here. So each time it moves, it's going to move above the 0 level of the probe. Then the second option is how deep the probe is gonna test each point. If you have very pronunciated curve on your material, you have to increase this or lower, depending on your material. Maybe it's a good idea to have a little measure of the highest and lowest point where you want to engrave. And this is the point matrix of the skein. If you lower this, you're going to have less points, as you can see on the image. The more points you have, the better quality is going to be the mapping regarding your surface. If you only want to engrave if you want to level on the surface, maybe less points are going to be needed. But we're gonna engrave this on a very spherical surface. So I'm going to use 8, 7, I think 6 by 7 by 5. Let's make one more. And if you can see, the number of points that you're going to test are going to be 63. Also, C feed. This is important too. This is how the speed for the probing on the C axis. If this is slow, it's going to take a long time to map all these points. So the default is it's 250, if I remember correctly. I upper this to 400 and it works okay. And the last two options is manual 0 or auto 0. If you put auto 0, automatically the script that makes the toolpath that is made with this, the first thing that it does is find the 0 automatically for you with the probe. Okay, now we're going to send the toolpath back to the UCCNC, and remember, put here to manual 0, because we are going to find the 0 for the 3D probe and the 0 for the endmill, and we're going to find the difference between both to have the exact 0 for 2. Okay, let's send the G-code back. Okay, if you see here, there is a new toolpath that's going to have all the probing first, and then we're going to have the engraving part. Okay, the first thing that we need to do is to find out the difference between the height of the C of our endmill and the probe, because they are different in height. So we need to find how much is the difference between these two. And what we're gonna do is test the 0 for one and then the 0 for the other. There's gonna be a little variation in here, because when you mount this here, there's a little play, so you have to be certain that you push this and press so it doesn't move. Okay, first let's measure the endmill first. Okay, what we're gonna need is our 0 length sensor. We're gonna measure here by the table, so we're gonna have the same position for both. I set up the endmill, and let's run this to find the 0 on the table. Now that it's proved, I need to take out the sensor and go to 0. Let's see. That's the 0. Go to the machine coordinates and let's write that number down on the C axis. That's the 0 for the endmill. And let's test the 3D probe the same way, but remember, you have to switch between both of the tools. Okay, it's very important to switch the tools, because if you don't switch the tools, you're going to break the 3D probe. One of the things that you can do to make certain that the probe is working, go here to diagnostics, and when you connect the probe, this LED is gonna be off, and if you touch the probe is gonna light this LED. Okay, that's how you can test that the probe is working, or the 3D sensor is the tool length sensor is working. Please check that twice, because it's very easy to break the 3D sensor if you are not if the probe is not connected. Okay, now let's take out the spindle and let's put the 3D probe to measure the other coordinate. Okay, now we need to change the spindle for the probe. I don't know if I mentioned you this, but with these two adapters, the probe fits really nice. These adapters are for the pen adjustment. So remember, you have to press here and push here, not to get this there, and you're gonna get the same measure every time. Okay, now we need to find the 0 for the 3D length sensor, and we're gonna run the 900 macro that I provide here with the files. Sorry that I didn't mention that macro. You have to install it on your macro profiles, like the 331 macro. Okay, to run it, go here to the MDI and let's spray macro 900, and this is the macro that's going to find the 0 for the 3D length sensor. Okay, let's run it. Now that we have the value of the C height, we're going to write this value. Okay, after we have the two values for the endmill and for the 3D probe, we get these two values. The endmill gets down 102.06 millimeters, and the probe it's minus 97. So what this means is that the probe is larger than the endmill, because the endmill gets lower. So the difference between those two, it's 5. We have to add this 5 negative to the endmill, so the endmill is going to be at the same level as the probe. We can do that by hand, getting lower the endmill until we reach this value, or we can do it with a command like the G0 or G01. Let's do it manually. Let's add 5 millimeters to the 0 of the endmill, and we are going to be ready. Okay, I put the 3D probe on the center of the object. Now to prove the 0 for the 3D probe, I have to run the 900 macro that came with the other files. So I write here 900. Remember to make sure that the probe is working. Okay, double check that, please, because you can break the tool if you don't do it. On the diagnostics here on the probe, you can check if it's working, putting the finger on the probe, and this is gonna light. Okay, remember, it's very, very important to be sure that the 3D probe is working. Okay, now let's run the M900. Okay, now that we have that, we can check the 0 coordinate for the 3D probe. We're gonna cycle start this, and it's going to start probing. Okay, let's press start and see how it's gonna map the surface. Okay, now what we're gonna do it's to switch between the probe and the endmill. We're gonna have to change the 0 for the C axis with the offset that we find at the beginning, and let's make the mill. Let's remove it to the probe. And now let's move the gantry to 0. Okay, now the gantry is on 0, and let's put the end mill, and let's see that it's going to be 5 millimeters upper the material. Okay, let me show you. Now we're gonna make those 5 millimeters down for the C. I'm gonna put the end mill here, so I get lower the end mill 5 millimeters, then put the 0 for the C only, move it to the 0, and it's going to be here, right on top. Okay, now that we change the end mill, the spindle, remember that we have the 24 for the material, and because there is a 5 millimeters difference, we have to lower down 5 millimeters this axis. So we can lower this value and do it by hand. 2, 3, 4, 5. There it is. Just oh, there. Now let's zero only the C axis, and now if we go to 0, the end mill is going to be on top of the material and ready to mill. Okay, let's press go to 0. Now let's press the start, and the script is going to resume the work and start the milling. Let's see it. Okay, now let's see the result. And here is the result. Well, I hope you find this tutorial informative, and oops, sorry. If you have any questions, I'm trying to put some light here so you can see the engrave. And look at the surface, it's really almost a sphere. Well, if you have any questions, please put it there on the Facebook page, and I'm glad to answer these questions. Okay, well, this is the final result. Take care, everyone, and I see you on the next video. I'm going to show you the macros that I made and how what they do, each one of them. Okay, see you. Bye.